Good morning, juniors. I hope you're having a great day. Today, we're going to be looking at our second day of factoring. We're going to be looking at special cases, but in order to do that, do these common squares first. So 1 squared, we know that that's going to be equal to 1 times 1, which is 1. Oops, I need to put on the pen here. So 1 times 1 equals 1. And then 2 times 2, write that in. You can just pause it right now and finish this. All right, welcome back. So we know that 2 times 2 is 4, 3 times 3 is 9, or 3 squared is 9, 4 squared, 16. And the reason why we're doing these perfect squares is that we're going to be looking for these numbers when we're trying to factor, and these are going to be some special cases that are going to help us out. So if we just go through the list here, 10 times 10 is 100. And then not only common squares, but we're going to have to be looking for patterns with cubes as well. So cubes are where you multiply a number times itself 3 times. So 1 times 1 times 1 is going to be 1. So if we have a number 1, we can know that that's going to be the same as 1 cubed. So pause it again and go through these numbers as well. All right, welcome back. So we know 2 cubed, so 2 times 2 times 2. 2 times 2 is 4. 4 times 2 is 8. And then 3 cubed, we get 27. 4 cubed, we get 64. 5 cubed, we get 125. And now I'm really stretching it here to my memory because I really don't remember after that, but I think 6 cubed is 216. And I'm actually going to pause it here and get the calculator out. So let's look at 6 cubed. So 6, raise that to the 3rd power, and we get 216. All right, so my memory serves correct. I think 7 cubed is 343. So 7 cubed, 343, so I can write that in. Whoops. And then back to the calculator. Oh, there, where'd it go? Here we go. So 8 cubed. One thing you may notice too that my cursor now tracks, I ended up purchasing a sketch pad so that you can see what I'm actually, where my cursor is, so I can point things out instead of having to underline them. So hopefully this works better than using the smartboard. So 9 cubed, we have 729, so 729. And 10 cubed, 10 times 10 is 100. 100 times 10 gives us 1,000. So that one we don't necessarily need a calculator for. And maybe you didn't for the other ones. So again, these are the numbers that we're looking for. Most common ones that we'll be seeing are these ones. And maybe we'll see some of these other ones. And oops, I didn't even write 1,000 there. There we go, 1,000. So these are the ones that we'll probably mostly see for common cubes, and then all these perfect squares as well. All right, so let's look at our agenda for today. So notice that last class we looked at simple factoring. We looked at RS method. Again, I'm having troubles drawing stars. Special cases is what we're going to be looking at today. So special cases, notice that we're going to try a productive struggle. It's, we'll see how that works as well. And then notes, we'll factor some special cases, and we'll take some notes, and then we'll be doing some practice as well. And again, I'm going to try to keep these under 15 minutes. So if it seems fast, rewatch it. So our objective, we're going to factor polynomials completely using sum and difference of cubes and other methods. These other methods, we'll talk about those as well. So let's get to it. So what's going to be helpful for you is to read through this. So it says, through this productive struggle, you discover 3 special cases of factoring polynomials. So multiply the 2 binomials and pause it now. All right, so we're back. So when we're multiplying 2 binomials, a times a is going to be a squared. And a times b is going to be plus ab. And then negative b times a is going to be negative ab. So we'll write a first in that. And then negative b times positive b is going to be negative b squared. So if we do some simplifying, notice that this part cancels out. So we really are just left with a squared minus b squared. So we can write on this line here, a squared minus b squared. All right, so let's look at our next one. So now let's multiply these 2 binomials. So we have a minus b times a squared plus ab plus b squared. So pause it now and work it out. All right, we're back. So you notice that a needs to multiply to all three parts. So it's a times a squared is going to be a cubed. And then a times ab is going to be plus a squared b. A times b squared is going to be plus ab squared. And then we'll do the same. We'll do a negative b times a, so that's minus a squared b. Notice that I'm writing the a term first. Negative b times a positive ab is going to be minus ab squared. And then negative b times a positive b squared is going to be negative b cubed. So what we can see then is some things are going to cancel out. We have a squared b, negative, positive, those cancel out. We have ab squared. Oops, I forgot to put the b in this one, it looks like. So let me just squeeze that b in there, because that should have been ab squared. So we did negative b times ab. That would have been negative ab squared. All right, so then we can see that those two cancel out. So the ones with the squiggly lines, that's the same thing, but one's positive, one's negative. So we end up with a cubed minus b cubed. All right, so that's the second one. So notice that we have this idea here. All right, so let's go on to the third one here. So now we're going to multiply these two. So we have a plus b times a squared minus ab plus b squared. So a times a squared, do that, work through it, and pause it now. All right, we're back. So we have a cubed. So a times a squared is a cubed. A times negative ab is going to be minus a squared b. And you may already notice that things are probably going to cancel out. We have a similar pattern here. So a times positive b squared, so it would be plus ab squared. And then we'll do positive b times a, so that'll be plus a squared b. And b times negative ab, so that'll be minus ab squared. And then b times b squared will be plus b cubed. All right, so let's look at some stuff here. So the things I'm underlining, a squared b, negative, positive, cancel out. ab squared, negative ab squared, same thing. One's positive, one's negative, so we can cancel those out. And we're left with a cubed plus b cubed. So a cubed plus b cubed is the same as those two things being multiplied. So look at the bottom here. It says the three equations you just wrote are special cases known as difference of squares, difference of cubes, and sum of cubes. And what we're going to do is we're going to use these backwards. So we're going to be using this a cubed plus b. If we see that pattern, then we can rewrite it as this factor. So let's look at some examples of what that'll look like. So difference of squares, notice that I wrote it backwards. So rewrite it this way, because now we're going to look for when it's a squared minus b squared, what we're going to do is we're going to write it as a plus b and a times a minus b. So if we have 9x squared minus 4, at first look, this may not look like two squares, but 9x squared is the same as 3x times 3x, or 3x squared. And then minus 4 can also be written as 2 squared. So notice that a in this case is b, or is 3x, and notice that b is 2. So if I was to rewrite this pattern below it, I can see that it's going to be 3x plus 2, 3x minus 2. So let's write 3x plus 2 and 3x minus 2. And that's going to be the same as 9x squared minus 4. So if we multiply that back together, we'd get this again. So notice that we're factoring the expression completely. This will be my final answer here. We're factoring the expression completely. We're seeing what can we factor, and we're looking for these patterns. So something squared minus something squared. All right, let's look at another one. So if we have sum of cubes, so this is where we have two things being cubed. So if we have something cubed plus something cubed, then we can rewrite it as this. And notice that this is a little bit more involved than the last one. It's going to be a plus b, then a squared minus ab plus b squared. This is going to be a little harder to see, but let's work it out. So we have ax cubed plus 27. 8 is one of those perfect cubes. 8 is the same as, we could write this as 2 cubed and x cubed. 27 is the same as, that's right, 3 cubed. So what we can do then is we can rewrite this as 2x is being cubed and then plus 3 cubed. So what is my a in this case? That's right, it's 2x. What is my b? That's right, it's 3. So now I'm just going to rewrite this, a plus b. So I'm going to write 2x plus 3, then 2x squared minus 2x times 3 plus 3 squared. So let's rewrite that over here. So again, I said I was going to do a plus b, so 2x, and then plus 3. And then I'm also going to do 2x is going to be squared now because that's my a. I need to put that in parentheses because it's 2x times 2x minus 2x times 3. Oops, I did like a double x there. That's weird. Let me just erase that. All right, so 2x times 3x, or times 3. And then now we do 3 squared because that was b, so 3 squared. All right, and then we just need to do some simplifying here. Does 2x plus 3 simplify? We're like, nope, that just still stays 2x plus 3. And then now we have this 2x times 2x would be 4x squared. Let me help, let's see here. I'm getting a little sloppy here. So we have 4x squared. Negative 2x times 3 would be a negative 6x. And then 3 times 3 would be plus 12, or plus, I'm sorry, 9. Well, let's do some fixing up here. All right, so we have 2x plus 3, and then 4x squared minus 6x plus 9. So let me get that 2x plus 3 in again. That part didn't change. It just looked sloppy because my handwriting went a little dull there. All right, so then this is what it would simplify to. And there's no more factoring you can do here. This part does not factor. That's not a quadratic, but you can try the RS method, but it will not factor. All right, so let's keep moving on here. So those are our 3 things we're going to be looking for. We already did difference of cubes, didn't we? Oh, we did difference of squares, sum of cubes. Now difference of cubes. Notice that this one, we have a similar idea. So we have a cubed minus b cubed. Now it's a minus b, and then the a squared plus ab plus b squared. If you look at this closely with the difference with the sum of cubes, the only difference is this plus sign, or this minus sign here, and this plus sign change spots. Otherwise, they're really the exact same thing. And I'm going to erase this part here. So let's look at this next one. So we have 64x cubed. So 64 is the same as, that's right, that's the same as 4 cubed, x cubed. And this is a tricky one. 1 is the same as 1 cubed. So 1's always going to be this one that it's harder to find or to see. So 4 cubed x cubed is the same as 4x cubed, the quantity, and then minus 1 cubed. So in this case, a is going to be 4x and b is going to be 1. So now I'm just going to basically substitute 4x in for a, and then I'm going to substitute 1 in for b there, and b there. All right, so let's do this. So we have 4x minus 1, 4x squared. So I'm going to do parentheses again. So 4x is being squared plus 4x times 1 is the same as just 4x. And then 1 squared is the same as 1 times 1, which is just be 1. So now we have to, the only thing notice we have to simplify is this 4x squared. So we have 4x minus 1, and we have 4x times 4x is going to be 16x squared plus 4x plus 1. And then this is my fully simplified answer here. I can't do any more simplifying from here. All right, so what I was going to say last time, so again, notice that we have these three things. We have difference of squares we're looking for sum of cubes, and we're looking for difference of cubes. So the 5 problems you do for homework tonight should be, actually it's might be 6 problems. It's 6 problems. So let's go ahead to that. Oops. So back to the answer key. So this was for practice 1. So this is your homework that was due yesterday. So you can see 1, 2, and 3. If you have questions on these, make sure you're seeking me out to get explanations. I have no problem doing that for you. You can either do email or on Google Classroom. And then here's 4 and 5. One thing to note, make sure on number 5 that you're multiplying. It's length times width times height. So you're multiplying these 3 things. So you're multiplying 3x plus 1 times x, and then also times x plus 3. And I should really have volume equals that. We should say that there. So volume equals. All right. Oh, and I just factored this one. I didn't even solve it. So I actually have to solve this one. This is equal to 0. All right, finding some mistakes. This is good. All right, so x equals 0. X equals a positive 6, switch the sign. X equals negative 4, switch the sign. So x equals, and let's put these in the squiggly line bracket. All right, so we have negative 4, 0, and a positive 6. Great. All right, and then this is your homework assignment for tonight. Practice 2, this is 1 through 3. So again, we're looking for difference of squares, and we're looking for difference of cubes. If we can simple factor first, check out this one. What can you divide both by? And then do some simple factoring. Then look for difference of squares. And then 4 and 5 and 6. Again, try to do some simple factoring first, then see if you have difference of squares or difference of cubes or sum of cubes. All right, so those are your homework assignments. And then for your ticket out, if you can try by memory, complete the special cases of factoring. We have a squared minus b squared. What's that equal? A cubed minus b cubed, and a cubed plus b cubed. So write those out. These are going to be things that you're going to want to be familiar with so that you can see the pattern and then you know what it factors to. Hope you have a great day. Again, let me know if you have questions. Let me know if things are going well for you or if they're not going well for you. I need to know in order to be able to help you. So sorry this went over by 3 minutes than what I expected. I will try to trim things down or be less long-winded in the future. Have a great day. Bye.